should be really comfortable with computing derivatives. We've done it all year. Okay, all the different types of ones. All right. Now, one thing that we really haven't done is this right here, the derivative of the inverse of a function. And I'm not even going to teach it right now. For those of you who really want a 5, you need to read this. And it's not really that hard. I'm not teaching it though. If you're like, I just want a 3, then here's what you're going to do. You're going to not read this, and you're going to skip number 18. Okay? There may be one question, and there may be no questions. Okay? And a lot of these, you can get out of having to do this. This is why I don't make a big deal out of it. All right? And there's a lot of AB teachers that don't teach this. Okay, so I'm going to move on. So just know, number 18, you don't know how to do that. That's okay. All right, so let's look at this. We're going to complete this worksheet. It says these rules should be memorized. They're also on your yellow card. So we're going to write them down here. At some point, they're going to make it to your yellow card, and you don't have to do that also today. You may want to do that like tomorrow or this weekend or something, just as review. But definition of the derivative. This, we already talked about yesterday, but this is the whole limit as h approaches 0, f of x plus h minus f of x all over h. You're going to get a little bit more practice of that on this packet. Okay, sum and difference rule. This just means, hey, if you're taking the derivative of something plus or minus something else, you're just going to take the derivative and then you're going to add or subtract it to the next thing. It's just take the derivative of each piece at a time. Pluses and minuses, easy to split up. Okay, same thing with the constant multiple. If you're taking a derivative of 5 times something, it's just 5 times the derivative. These are all rules you probably internalized, and you may not have seen it as a rule since we first learned it. And that's, if this is more confusing to you, then you may just want to not do it. I don't know. Product rule. This is something you really need to know how to do. The whole idea with product rule is that you understand that there's a plus, okay? You can't just take derivative times derivative. That's the biggest mistake people make with product rule. That's not even doing product rule. It doesn't really matter the order of all this stuff. Quotient rule, the order does matter. It needs to go derivative of the top times the bottom minus, for quotient rule, the top times derivative of the bottom over the bottom squared. Okay, chain rule. Remember, you take the derivative of the outside part first. What initially happens to the inside part of chain rule? It stays the exact same. Then you go times the derivative of the inside. on your yellow card, these use U and V, by the way, instead of F and G. Totally fine. It'll be a good practice to write it down different ways. Okay, power rule. What do you do when you have an exponent? You put it to the front, and then what happens to the power? Subtract 1. That's just your basic power rule. Okay, on y'all's, I whited this out because we don't do this, and I just didn't do it here. Same thing there. We don't do that. Okay, what's the derivative of e to the u? E to the u times u prime. Good. Has to be times u prime. Okay, I'm going to go back up, but I'll scroll down, so if you miss something, you'll get it on the second go around. Okay, what's derivative of sine u? Cosine u times u prime. These are all going to be times u prime. Because if you're not just doing sine x, if you're doing sine x squared, you have to account for that with the chain rule. Okay, what about derivative of cosine u? Negative sine u times u prime. Okay, what about tan u? Secant squared u times u prime. U prime is just the derivative of the inside part. This may not be the order you're used to, and that's totally fine. You might be used to doing cotangent next, which would be negative cosecant squared u. Remember the cos, it's just negative, and then the we just everything. So yeah, so I skipped down here. So secant u would be secant u, tan u, u prime. So cosecant u would be negative cosecant u, cotangent u, times u prime. You got to be familiar with all of these trig, all 6 trig. You got to be able to go both ways. Like we're going to do integration more next week. You got to be able to integrate these things as well. Okay, what about the derivative of natural log? Yeah, it's 1 over u times u prime, or you may be more used to seeing it like this, u prime over u. They mean the same thing. Whether you're going times u prime or putting u prime in the top, it means the same thing. Okay, inverse trig. These were the last derivatives that we learned. We talked about it in December, but you may or may not remember this. It's going to be 1 over 1 minus u squared times u prime, or you could write it with u prime on top. We've kind of seen it both ways. You just got to make sure that u prime gets in there. Okay, now that I've shown you arcsine, do you remember how arctan is different? Yeah, there's no square root and there's a plus. But the same idea. Okay, so these are all the derivative rules you need to know. You see them on the right side of your yellow card. At some point this week, it needs to be transferred to your yellow card. And that way, you don't have to go back and look it all up through this packet. You don't have to do that right now. Okay, as you look through these problems, there are going to be some using definition of derivative. You're going to have some trig, some basic derivative. You're going to be plugging in points. You're going to be looking at charts. Okay, and then I was hoping to look at least. Okay, number 10, you got to do implicit differentiation. Okay, so you got to remember the whole dy over dx. Every time you take derivative of a y term, you write that, and that's what you're getting by itself. Okay, I'm not going to work any of these out because I feel like we've done this in the recent past.